Okay, Alistair here, and I'm going to talk a little bit about this machine and its problems, or a problem. This is a cylinder grinder. It's made by RUR in Italy. It's a nice machine. It's not a Jones and Shipman, but it does the job. But the problem we got with it is the table motor has failed. That's the motor that moves the spindle backwards and forwards in front of the grinding wheel. So this is the basic machine, and this is the electrical box in here. Lots of interesting old bits of stuff in there. And the problem we have around the back here, where there used to be a motor down there on those 4 holes. There's 4 holes there, and there's the pulley down there, there's the belts, and there's the remaining wiring. Here's a connection box here of some of the wiring, and the problem we got is this motor died. I'll go over to the bench and show you the motor. Hi there, Alistair here. I want to talk a little bit about the cylinder grinder I've got, this RUR cylinder grinder, which is an Italian cylinder grinder. It's a nice machine. It's about the size I want, and I picked it up second hand from a tool dealer who, well, it's just really surplus to requirements. It's out of a college, so hopefully it's not got too much wear. But it has got a problem, and one of the problems is the table feed motor doesn't work. And it had a lot of water in it. Don't know where the water came from, but it's got water in it. So you might think, well, that's dead easy, just get another motor. Well, that's what I thought, but being Italian and being old, it's not a standard motor. It's a thing called an 8-pole motor, and it's a little unusual in that it's a low horsepower 8-pole motor. Now, for those of you who don't know much about poles, it doesn't really matter as long as you understand that AC motors or asynchronous motors run according to the frequency of the mains, 50 Hertz, 60 Hertz, depending where you are in the world. We're in Canada here, so it's 60 Hertz. So the motors have set speeds depending on the number of poles. The minimum you can have is 2 poles, which gives you 3,600 RPM. And you can work this out, and there's no doubt there's tons of information on the internet about this, but basically your RPMs are 3,600, 1,800, 1,200 and 900, which are the more common ones. There are others which go on and on and on if you're getting great big motors, but generally they are the most common ones. So they're not exactly 3,600 and they're not exactly 1,800, they're about 1,725. That's to allow for the slip of the rotor. Again, you don't really need to worry too much about that, just look on the plate and it will tell you the RPM. But the basic principle is there's 2, 4, 6 and 8 pole. Now, these different speeds were for different applications. Whatever your application was. Conveyor belts used to use slow speed motors quite a lot. But low horsepower slow speed motors are now quite a rarity. So you cannot easily go and buy a small low horsepower 8-pole motor. The highest they go now is 6-pole, which is 1,200 RPM. So what do you do about this? Well, nowadays they don't have these motors. This particular motor I'm talking about here was made in 1963. In those days, inverters were not really common at all. Very rarely ever saw one. Very, very expensive, and so you just used a gearbox or a motor. Or there were some other very expensive types of motor, or you converted it to DC and used a different kind of controller using a mark space ratio. There was other ways, but nowadays we have lovely things called VFDs, variable frequency drives, which are common and cheap, and it's the way most people do different speeds on motors or variable speed motors these days for 3-phase. So what can we do here? Well, this is an 850 RPM motor. It is an Italian motor and the horsepower rating on it is CAV. Well, that's stumped me for a while, because what is CAV? Well, I think it comes from Chaville, or is an Italian word for horse, and it was a very common thing on motors in those days to see CAV or CV, which was their equivalent of horsepower. So it's just 0.3 horsepower. So we have a 0.3 horsepower, 850 RPM, 60 Hertz, 220 volt, 3-phase motor. It's actually 220 volts or 440 volts, so it's got a dual voltage winding in there, and it's continuously rated, and it's 3-phase. Well, to get one of these motors, I could either get this motor rewound, which is $1,000+ and things in life have always taught me, okay, so we get this motor rewound. Now what do we have? Well, we have a very odd, obscure motor on the back of our machine that's been rewound. It's not available anywhere, so I didn't really think that was a good idea. Plus it was $1,000, so it was a lot, plus over $1,000, so what's the point? I'm going to end up with a very rare motor that nobody can replace. So I thought, well, I'll put a small VFD on it. So that's what I'm going to do. But to put a variable frequency drive on it, it's obviously a little different, because this motor has to reverse. That's how the table goes backwards and forwards, so it reverses the motor. Well, on VFDs these days, there's usually some controls where you can reverse it via switching. And there is on the VFD that I have purchased. So it's a lens VFD. I'll show a little bit more of that later. But I want to point out the two motors I've chosen to replace this. Now, if you're going to replace a motor that is a low horsepower motor of low speed, and you want to replace it with another motor that's of a higher speed, obviously the lower speed motor will have more torque than the equivalent horsepower at a higher speed, because that's how horsepower and torque works. So if you halve the speed, you halve the horsepower, halve the torque, half the horsepower, and if you double the speed and keep the torque the same, you've doubled the horsepower. So we need to find a motor with the same torque as this motor. Although they'll tell you, and the VFD guys say that they can maintain the torque down low, or increase the torque to maintain the horsepower. Well, I kind of find that a little hard to believe. They probably can do it to some extent, but you would have to increase the voltage going to the motor to get more current going through it at a lower speed, and there will be limits to all that. So the best thing to do is to, if you're going to double the speed, which is what we're going to do here, you will need to also double the horsepower to maintain the torque. So what I've done, I've chosen a 1 horsepower 1750 RPM motor, and we're going to use a VFD to change the speed to about 800 to 900 RPM or 850 RPM, and it will have a similar torque to this 3rd horsepower motor. So bear that in mind if you're going to use a higher speed motor in place of a lower speed motor. You will need to recalculate to get the torque the same, because as you go down in speed, the torque of a motor is roughly constant, so the horsepower goes down. So this motor at about 900 RPM, which is half its rated speed, or 850, will have to have double the horsepower to have the same speed as a half horsepower motor running at that speed. This is a 3rd horsepower motor, so we should have plenty. Anyway, I'll now show you the two motors. Here's the plate on the Italian motor, It's an Enrico Bezzi. I think you can see all the numbers there. And this is the motor. Here it is. And this is the motor we're going to replace it with. I'll get it around the right way. And here we have, you can see that. That is the plate on that motor. So it's a 1 horsepower, 1725 RPM motor. It's actually got a surface factor of 1.15. There's the connections. Okay. Now the frame on this motor, there's the actual motor. The frame on this motor is different to the other motor, of course. If we find the frame on here, it will be on here somewhere. Yes, it's a 56C. There's the frame. There it is. There's the frame. So that will not be compatible with the motor that we're replacing it. The shaft size will be different. There's the pulley. This is the pulley that has got to go on these two machines, or this machine. It has an 18mm hole in it, and this has a 5/8 shaft. So that's got to be fixed. So we've got a few mechanical problems to get over. The holes are in a different place, the pulley's a different size, and the motor goes a different speed. So we've got to fix all those problems to replace this motor. And I thought I'd make a little video of how I'm going to go about doing all of that. Okay, here we are in the electrical cabinet. As you can see, wires, contactors, stuff everywhere. Looks enormously complicated. It's actually not too bad. This is what we're going to be concerned with. This contactor here, the power is all off and it's unplugged, so there's no power on here. This one is two contactors together. There's one here and there's one behind here. And this, you can tell by the, just telling there, you see the crossed over wires. This is a reversing set. So when these contactors are operated, one makes the motor go one way, one makes the motor go the other way, and it goes between the two, and it's controlled by a switch which is operated over here on the grinding machine. That makes it go backwards and forwards. So we've got to get this thing out, get the inverter in and program it and start making sure it all works. Now before I actually screw everything into this cabinet, I'm going to make sure we got it programmed correctly, wired up and so on and so forth. So the first thing to do is to get this thing out of here and find the switch wires. So I'm going to do that. I'm not going to record all of that because it's a fiddly job and it takes some time, but I'm going to get this out of here now and find out where all the wires are. Okay, I've now got this electrical panel somewhere near where I need it to be. Here's the old contactor block that came out, no longer required. So what we need some power, we need some connections to a motor, and we need a switch to make this VFD work. So we have, here is the switch. This is the changeover switch that is used to control the direction of the motor. We're actually not going to use all of that. These three wires here are power to the VFD. That's these three here going down to the VFD down there, which I'll talk about a bit more in a minute. And these are the three wires which go to the motor. So, and they are labelled T3. And yes, T number 5, T3, T2 and T1, and they are wire connections number 5 on this machine. So there we have it. That's the motor which goes to the back. That would be our power, and this is our switch. So now what we have to do, we have to make all these things work in the VFD and control the speed at half speed. So that's basically all I've had to do in this box, and connect a couple of wires together here to make it still work. So it took me a while to get round the wiring and find out how it all worked. I still don't know everything about this, but it doesn't really matter because it still functions, so that's good enough for me. I lost the light bulb, by the way. It broke on the way coming out, so I'll have to get a new light bulb. I've got a switch down here, this switch, which I can use to turn it on and off with. So that's the box where it's going to go. It's going to go basically in there like that. That's where it's going, and I'll screw it in there with a couple of screws, no problem. And now I'm going to talk a little bit about the VFD. Okay, here we have it. This is the VFD. This is a Lens AC Tech VFD, or SMV as they call it, vector drive thingy. It's all the same thing. Variable frequency drive. Nothing really very unusual about this, bog standard. You can get them all over the place. But you have to make sure you get them right for your power. The input power is determined by the type of VFD you have. This one, the model number is, if I can get it right, there it is, that's the model number, and this will determine what the input power is. The input for this is 240 volts, 3-phase, and there it is there. That's the input voltage that you can put into it. And the output is 3-phase. There we are, it does up to 1 horsepower, so on and so forth. So that's this machine here. And I'm now going to talk about how I programmed it. Okay, here we are in a manual, and we're at program number 100. Start control source. So what do we want this VFD to do? Well, we want to be able to turn it on remotely, and we want to be able to reverse it remotely. That's what we want it to do. And we want to instantly reverse from one direction to the other, controlled by the switch. So we need this to be controlled from the terminal strip, and there we have to program number 4. So when we go into programming, we first select program P100, press the button again, and increment to number 4, which will mean that it will be terminal strip and local keypad mode. So you can operate it from the keypad or from the terminal strip. So that's the first programming change we have to make. Most of these are defaults, and you don't really have to do anything much with them. Now, the next one we have to deal with is 104 and 105. So there's 104. There, 104 and 105. Acceleration and deceleration time. The default is 20 seconds. We want instant acceleration and deceleration. Well, that's pretty hard on the unit, instant, so I set this one to 0.2 seconds. So 0.2 acceleration and 0.2 deceleration. A little bit kinder on the electronics. So it doesn't need to be absolutely instant, so I did that. So that's, I think, we have to do. We have to make sure that the minimum and maximum frequencies are 0 and 60 Hertz, but again that's the default, so we don't have to worry about it really. There they are. So 60 Hertz, default is 0. There are maximum frequency, default is 6. So that's all sorted. The next bit we have to come to is this area here. P120, 121, 122 and 123. You're allowed to do all sorts of things with the terminals here. to control your VFD. But the easiest thing to do is turn the page, and they have a nice little circuit here. There's 2 or 3 ways to run the motor, and this one is the one I'm going to use. It says here, run stop with direction, which is what I want. Be able to change the direction, run and stop. There's our circuit. 1 switch and 2 switches. And they're on pins 1, pin 4 and 13A. And the program setting is P121 and set it to 10. So if we go back over here, P121 is over here. There's 121. And we're going to do it on TB13A, that's terminal block 13A, and we're going to set it to 10. And at 10 says reverse rotation, open equals forward, closed equals reverse. So if we connect pin 4 to pin TB13A, or terminal block 13A, it will change the direction whether it is closed or open. And also the stop will work, stop and start, whether pin 4 is connected to pin 1, as on the circuit there. So that's what I've done. I've programmed it in. It's pretty easy to do. This is the button on the front here. You've got M, which is the program button, and that will go into program mode. You press it again and it will set the program parameter, which is on these buttons here, there and there. So it's as easy as that. These are pretty easy to use, these now. They really are great little things. This one will actually convert single phase to 3-phase on a small motor, so, but not this particular model. There's another model very similar to this, with single phase input, and you can have 3-phase output. This one is 3-phase in with 3-phase out, but it controls the speed. The actual speed is controlled from the front panel with the up and down buttons when it's in the run mode, and it remains there unless you change it. Even though you switch the unit off, it still comes back at the same speed. So that's the VFD, and now we're going to proceed to connect things up and get the motor installed. Here we are in the electrical box. I've mounted the VFD and I'm about to wire it all up. We've programmed it, so the program's in there. So we're nearly there. I've just got to do some connections and tidying up, and it might even work. You never know your luck. Okay, this is the conclusion of the repair of the cylinder grinder. Here you can see the mechanism that I've had to create for a toggle switch, just a little bracket really. And you can see it operating the toggle switch there to change the direction of the table. And here's the table moving, as you can see. It doesn't move very fast. You can see it moving backwards and forwards. Here's the little lever on the machine. Anyway, I'll put this back together and you can see it with the cover on, and that'll be the conclusion of it really. Well, here we are. This is the last little installment. This is so you can see the machine actually working. You can see the table reversing. There it is here. This is a RUR 500 Italian cylinder grinder. Seems to be a fairly good machine. I'm quite impressed with the quality of work it produces. And it's quite adjustable. This head here swivels, goes in and out as well. And this head also swivels. It has the internal spindle turning attachment as well. I put that new chuck on there, so we have a chuck, a way out of chuck. That seems to work very well. This one's really finishing off, and some covers putting back on, and the oiler refitting, and then she'll be ready to go. So that's that thing fixed.